Artificial intelligence currently synthesizes thousands of lines of functional software code in seconds. The technical effort to write standard syntax has dropped to nearly zero. This velocity introduces a structural liability. Deploying AI agents to build software without rigid constraints allows technical debt to accumulate as fast as the code can be written, creating systems that humans cannot fully comprehend. A compiler will catch a syntax error, but it cannot identify a logic hallucination. When an AI misinterprets a business rule and embeds that flaw in the core architecture, the resulting failure is exponentially harder to extract. The critical bottleneck in modern engineering has shifted. It is no longer the act of typing code, but the act of defining precise, deterministic system design. To maintain control over AI-generated systems, engineering teams must prioritize the definition of intent over the act of generation. Requirements written in natural language, like paragraphs in a Word document, are too subjective to constrain a machine. They lack the structural rigor needed to guide an AI agent reliably. Spec-Driven Development, or SDD, addresses this by decoupling the intended behavior of a system from its underlying technical implementation. At the center of this workflow is a machine-readable specification file, typically YAML or JSON. This document serves as the executable source of truth, acting as a gatekeeper between human requirements and the AI code generator. By establishing the specification as the ultimate authority, teams stop the cycle of creating undocumented legacy code. The intent is fixed before a single line of implementation is written. Software development has previously attempted to align business intent with engineering through behavior-driven development. Traditional BDD relies on three layers: Gherkin requirements, implementation code, and a middle layer of step definitions. This middle layer requires manual translation. Because this depends on manual updates, it inevitably drifts. Tests and documentation fall out of sync with the code. Enterprise modernization projects face a similar failure when they attempt a lift and shift. Translating decades-old code directly into modern languages using AI simply moves the institutional knowledge from one syntax to another without ever documenting the logic. This kind of direct translation turns a new tech stack into a siloed, misunderstood legacy system on day one. Code, whether it is decades old or AI-generated, is not a reliable source of truth for system behavior. It is only the result of it. To correct this, the SpecOps methodology applies strict GitOps principles directly to system specifications. A SpecOps file is self-contained and modular. It defines system operations with enough precision that no external interpretation is required. Changes originate in the specification file, flowing to three outputs. First, it drives automated validation for fail-first testing. Second, it constrains AI code generators with exact scaffolding. Third, live documentation stays in sync. A single commit keeps everything perfectly aligned. This unidirectional flow closes the gap between the system's documented intent and its actual execution. By utilizing this framework, teams decouple the understanding of a system from the technical stack used to build it. The testing logic within this pipeline is governed by the fail-first mandate. A spec-driven specification is inherently executable. The system validates the requirements without requiring engineers to write separate test scripts or glue code. This requires the executable spec to run and fail before the AI is allowed to write any implementation code. This initial failure proves the spec is deterministic and unambiguous. If a requirement cannot be proven to fail, it cannot be trusted to pass. When the code finally causes the spec to pass, it provides objective verification that the AI has fulfilled the original business requirements. Moving toward this model involves a transition through the SDD maturity matrix. Level 1 is spec-aware. Humans write code using the specification as a passive reference. Level 2 is spec-led. AI agents generate boilerplate, which engineers review against the spec. Level 3 is spec as source. All code and documentation are automatically derived from the specification. This maturity model is supported by a robust developer ecosystem. Thousands of parsers, linters, and code generators already exist to execute OpenAPI and SDD specifications within an enterprise environment. The technical infrastructure is mature. The primary challenge for most organizations today is the shift in their internal workflow. Spec-driven development changes collaboration between product owners and engineers. Instead of debating implementation details, they work together on the structured specification interface. Engineering effort moves away from repetitive logic. Developers spend more time architecting system behaviors and defining edge cases that the AI must satisfy. The traditional code review is replaced by a rigorous spec review, where the intent is analyzed before the code is even generated. Identifying a logical flaw in the intent takes minutes. Debugging that same flaw in thousands of lines of AI-generated syntax takes significantly longer. Engineering teams are evolving into system architects, prioritizing the structural integrity of behaviors over the manual production of code. AI builds software faster than ever, but unconstrained speed is a liability. Maintaining rigorous control is the only way to ensure systemic stability. An AI codebase cannot reliably explain its own behavior or document its own growth to future engineers. Organizations that invest in machine-readable intent will build systems they actually understand. Those that rely purely on prompts will struggle to maintain systems that have grown too complex to manage. A pristine, executable specification preserves institutional knowledge. It ensures systemic agility, allowing the underlying technology to change while keeping the core business logic reliable. When code generation is instantaneous, writing faster stops being a competitive advantage. Success belongs to the organizations that can define their intent with total clarity.